Well, welcome to the first section of Chapter 6. We are going to be talking about polygons, and we are specifically going to be talking about the sum of the measures of both interior and exterior angles in polygons. And the first thing you're going to need to know is that the sum of those interior angles and the exterior angles is dependent upon the number of sides that each polygon has. And if we were actually to take the polygon and divide it into triangles, we would find out that the number of triangles it has is n minus 2, where n is the number of sides. And the sum of the angles in any polygon is related to that. If we divide it into triangles, then the sum of the measures of the interior angles is just the number of triangles, n minus 2, times 180. So just keep in mind that n minus 2 is how many triangles. If you have a four-sided figure, if you have a quadrilateral, and you put in 4 right here, 4 minus 2 is 2, that means we can divide every quadrilateral into two triangles. And so therefore it has 2 times 180, or 360 degrees in the interior angles. So let's go ahead and use that first theorem to find the sum of the interior angle measures of a heptagon. Well, I don't know if you know any of your polygon prefixes, so I went ahead and included a table here for you with the number of sides and what each polygon is called. I will expect you to know all of these in this table right here. Anything after 12 doesn't have a special name. It's just called an n-gon. So like if you had 15 sides, it would be called a 15-gon. In this problem we're going to do over here with 17 sides, it's called a 17-gon. So let's go back up to this one. Our polygon has 7 sides in this one, so we're going to use the polygon angle sum theorem, which says take the number of sides and subtract 2 and multiply that result by 180. So for a heptagon has 7 sides, so we're going to plug in the number 7 for n. 7 minus 2 gives us 5, and 5 times 180 gives us 900. So the sum of all of those angles inside that polygon is 900. You already know that the sum of the interior angles of a triangle is equal to 180, and you can use this same formula. A triangle has 3 sides, and 3 minus 2 is 1, and 1 times 180 is 180. So that's actually the formula you're using without even knowing it. So let's go ahead and do one with 17 sides. Again, we're going to use the exact same formula. So we want to use the n minus 2 times 180, and in this case we're going to use 17 for n. And 17 minus 2 is 15. And when we multiply 15 times 180, we get 2,700. So you can see that the more sides that we have, the larger the number of degrees we're going to have in our polygon when we add up all those interior angles. So here are 3 different pictures for you. The first one shows a polygon where all the side lengths are equal in length. Okay? And if that happens, we call that an equilateral polygon. In the middle one, we have all of the angles. The interior angles are equal in measure, and that is called an equiangular polygon. And the third one, when both the angles and the sides are congruent in measure, that's called a regular polygon. A regular polygon. You'll see that very, very often in the problems that we're going to be working with. So here's a corollary for our polygon angle sum theorem, and this says if we want to know the measure of each interior angle individually in a regular n-gon, what we're going to do is take that formula that we just had, n minus 2 times 180, that's the sum of the interior angles, and divide it by n, the number of sides. And that should make sense to you. If we wanted to know in a triangle, and it were a regular triangle where it's equilateral or equiangular, what the angle measures are, we're going to take n minus 2 times 180. We know that they add to 180 in a triangle, but then if we divide by 3 angles, each one of those is 60. So that's how we find the individual or each interior angle, by dividing by the number of sides. So let's go ahead and use that to solve some problems. This one has to do with the common housefly. And it turns out their eyes have like 4,000 different facets, and that's just another word for faces. And each one of those facets has the shape of a regular hexagon. A hexagon has 6 sides. This problem asks us what is the measure of each interior angle in one hexagonal face. So each of these interior angles, I've indicated that by the little yellow arrow here. We want to know what one of those angles is equal to. So what we're going to do is we're going to go ahead and use that formula that we just learned, the n minus 2 times 180 divided by n. So in this case, we're dealing with a hexagon which has 6 sides. So we're going to substitute the number 6 for the letter n everywhere we see n in our formula. We're going to replace that with the number 6. So we get 6 minus 2 times 180 divided by 6, which is 4 times 180, and that gives us a total of 120 degrees for each angle. Now be very careful with your order of operations here. Remember, you have to do that subtraction because it's in parentheses, so we have to do that subtraction first. Then once we have these multiplied and divided, we can do it in any order. You can multiply the 4 times 180 and then divide by 6. You could actually divide 180 by 6 and get 3 and multiply, or excuse me, and get 30 and multiply that 30 by 4 to get 120. So then the order of operations, whether you do multiplication or division first, does not matter. So here's one for you to try. What is the measure of each interior angle in a regular nonagon? Remember, regular means all the sides and angles are congruent. A nonagon has 9 sides. Go ahead and pause the video and we'll work through this together when you get back. Alright, I hope you gave that a try. Let's go ahead and work through this one. First thing you want to do is to go ahead and write your formula. And your formula is n minus 2 times 180 over n, and we're going to let n equal 9. When we plug in 9 there, we get 7 times 180 divided by 9, and that gives us a total of 140 degrees for each of those single interior angles of a nonagon. Problem number 3 says, using the Polygon angle sum theorem, what is the measure of angle y over here in the pentagon today? A pentagon has 5 sides, and this one has each vertex labeled, and it spells the word today. So we're going to use that same Polygon angle sum theorem where n is equal to 5. So the first thing we want to do is write an equation that we can solve. So if we just add up all of those interior angles, we know that the sum is equal to the n minus 2 times 180. And then we can substitute the ones that we know. We have 4 of the 5 given here. So we're going to go ahead and just plug in those numbers. So angle T is 110, angle O is 90, D is 120, A is 150. We're looking for Y, and we end up with 3 times 180. When we simplify and solve for Y, we end up with angle Y equaling 70 degrees. The exterior angles are formed in a polygon by just extending any of the sides. And the exterior angles, you can see, if you add all of the exterior angles in any polygon, every single time we get 360 degrees. So that gives us a polygon exterior angle sum theorem. And it says that the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360 degrees. And that's kind of interesting. So you could have 27 sides and it would still, the exterior angles would still sum to 360 degrees. So as you might expect, we're going to go ahead and solve some problems using that theorem. This one says, what is the measure of angle 1 in the regular octagon at the right? And angle 1, what we have to do then is just find what the sum of the measures of the exterior angles are and divide by how many sides we have. So the Polygon exterior angle sum theorem tells us that the sum of the exterior angles is 360. Since the octagon is regular, notice it says a regular octagon, which means all of the angles and sides are congruent. The interior angles are congruent, so their supplements, the exterior angles, are also congruent. So since they add to 360, how many exterior angles do we have? Well, we have 8 of those because it's an octagon, so all we need to do is divide 360 by 8, and that gives us 45 degrees for each exterior angle. Here's one for you to try. What's the measure of an exterior angle of a regular nonagon? Well, this one's going to be pretty straightforward. Just like the last example, all of the exterior angles will still add to 360. So what you're going to do is you're going to take 360 and you're going to divide that by how many sides you have. And in a nonagon we have 9 sides, so that gives us a total of 40 degrees for each exterior angle. So here's your lesson check. Please go through each of these problems on your own and bring your answers to class. We'll see you next time.